In this video, I'm going to show you how you can prove or disprove that if the quantity, if P then Q, then R, and if P, then the quantity, if Q, then R, are equivalent. To solve this problem, I will use a problem-solving plan that includes 3 steps. Step 1 is to understand the problem. In order to do this, I must determine 3 things. What is being asked? What do I know? And what do I need to find? Step 2 is to make a plan to solve. And step 3 is to solve. In this problem, I'm being asked to prove or disprove that if the quantity, if P then Q, then R, and if P, then the quantity, if Q, then R, are equivalent. I know that P, Q, and R are propositional variables. And this means that they represent propositional statements that are either true or false. I know that the implication connective, which is this arrow symbol, is being used with other propositions to represent conditional, or if-then, propositions. I need to find the truth values for these 2 compound propositions and determine whether they are equivalent. So now that I understand the problem and know what I need to find, I need to make a plan to solve. And my plan is to make a truth table to find the truth values for these 2 compound propositions. How do I do that? Well, I need to make enough rows in the table so that there is 1 for every combination of truth values for each propositional variable. I can find how many rows I will need by taking 2 to the n, where n is the number of propositions. Next, I need to map out the columns of the table. I need 1 column for each propositional variable, 1 for each compound proposition that occurs as the final compound propositions are built up, and 1 for each of the final compound propositions, which are these ones. After I complete my truth table, I can use it to determine whether the compound propositions are equivalent. And I can do this because 2 compound propositions are equivalent if and only if the columns in a truth table giving their truth values agree. Alright, now I am to the fun part where I get to solve. And because I already made up a pretty detailed plan, this should be easy. I know that I have 3 propositional variables, which means my truth table will have 2 to the 3rd, or 8 rows. This is not including the top row that will list the propositional variables and compound propositions. Next, I can create and title my columns, beginning with my propositional variables. I need a column for P, for Q, and for R. I will also need a column for each compound proposition that builds to make each of the 2 final compound propositions. So, I will need a column for if P then Q, and if Q then R. My last 2 columns will be the 2 final compound propositions that I wish to compare the truth values for. These are if the quantity, if P then Q, then R, and if P, then the quantity, if Q, then R. Next, I need to complete the first 3 columns with all the possible combinations of the propositional variables' truth values. They can be true or false, and I can represent this using a T or an F. Some people use 1s and 0s, but I like to stick to the T's and F's. So, all 3 can be true. The first 2 can be true. The first and last can be true. The last 2 can be true. All 3 can be false. The first 2 can be false. The first and last can be false. And finally, the last 2 can be false. For the next column, if P then Q means that if P is true, then Q is true. So for the first row, both P and Q are true, so the conditional statement is true. The same reasoning goes for the second row. For the third row, P is true, but Q is false. So, if P then Q is false, because we are saying if P is true, then Q must be true. The same reasoning goes for the very last row. For the remaining rows, P is false. So, no matter what Q is, if P then Q is true. This is because the conditional statement tells us that if P is true, then Q is true. This statement does not tell us a condition for when P is false. So in the case that P is false, if P then Q is always true. For the next column, this is another conditional statement, except now it is if Q then R. The same reasoning I just explained for the previous column can be used to determine the truth tables for this column. If Q and R are both true, then the conditional statement is true. If Q is true and R is false, then the conditional statement is false. Finally, if Q is false, then no matter what R is, the conditional statement is true. The last two columns can be completed in a similar fashion, except now we are using the final two compound propositions as shown. All right, now that the truth table is finally complete, we can determine whether the two compound propositions represented by the last two columns are equivalent. By comparing the truth values of each column, we can see that the two compound propositions are not equivalent. Therefore, we have disproved that if the quantity, if P then Q then R, and if P then the quantity, if Q then R, are equivalent. To conclude this video, I just wanted to say thank you so much for watching.